All right, so we are recording. We're going to do the 5.8 lesson. Since I've been blowing up on YouTube, I'm going to try and remain humble. But again, I ask you guys to subscribe, notify, smash the like button, just obliterate it. Just, just can't miss out on this stuff here. It's some really phenomenal stuff. So we are going to be doing 5.8, which is modeling with quadratic functions. So to model our quadratic functions, what we're going to basically be doing is given a set of information that we're able to create an equation with. So when we're looking at these things, we eventually hope that it changes, and it does. And so when we're looking at a problem like this, basically I'm giving you a vertex and I'm giving you another point on the graph. So what's special about doing these quadratic functions is basically if I have a vertex, I kind of have a lot of information. I'm able to use that in my equation. And as long as I have one other point in addition to the vertex, it doesn't matter where that point is on my parabola, I'm able to come up with an equation for it. So I'm going to take this information here and we're going to pop over to the old paint workshop to see if we can come up with an equation for this. So the first piece of information that I really need is how to find a spot to get the Zoom meeting out of the way and just not bugging us. So now we have that out of the way, we're going to start with our vertex, which is 2, -3. So now that I have my vertex, I say, okay, the other point that I have, which is on this graph, is 4, 1. And so now I'm saying, okay, well, if I've got this vertex, I've got this point, I'm pretty sure there was this thing that Mr. G talked about, it was like vertex form. So vertex form looks like this, y equals a, and then x minus h squared plus k. Now, when I give you the vertex, I'm really giving you h and k. So here my h value is 2. My k value is -3. I'm going to take those values and just plug them into this equation, and we're going to see that we don't know everything. So I might know a later, but for right now, I don't. So this is what it's going to look like just taking these two values and plugging them in. So right now I've got y is equal to a, and then I've got x minus 2. Again, why does it look like -2 here when my h value is +2? Is because it's minus h. That value all squared, oopsie, not plus, and then -3. So now I'm going to say, well, how on earth do I even solve this thing, right? It looks like I have 3 variables. Well, we actually have a point that works, right? We were given this point on our graph, so let's use this. So what is this point? This point is just an x and a y, right? So I'm going to take that x and y, and I'm going to use them in my equation here. So I'm going to take 4 and plug it in for my x. I'm going to take 1 and plug it in for my y. And so now I'm just looking at a single variable a that I'm able to solve for. So when I do this, I'm just going to do some math. So I got 4 minus 2 gives me 2. So I'll write out kind of every step here as we do the first one. That way don't lose anybody. A times 4 here, minus 3. And we all know that this is 4 times a minus 3. We are not going to do any sort of subtraction here because we have multiplication to do first. We're very busy people. We have to do our order of operations things. Here I got 4a minus 3 equal to 1. Add 3 to both sides. So I get 4 equals 4a. Divide by 4. Divide by 4. That 4 kind of looks like a y, but not anymore. And now we get a equals 1. Cool. All right. What is the significance of that? So now when I jump back in my equation, my a value here is going to be 1. So now I can write this thing out in terms of a final answer. I'm going to say y equals my a value here of 1, which we don't really need to write on the outside, but I don't know, it's kind of fun. Why not? And then I'm going to have my x minus my h value, and that thing is squared, plus my k value. So again, h and k came from my vertex here, so I'm going to try and keep the colors the same. So here we go, minus 2, and then we got plus. That was kind of in a weird spot. Oh my goodness, here we go, negative 3. And then we're just going to go through and simplify. So like if this was subtract a negative number, we want to change it to plus. Here we're adding a negative, so we're just going to simplify this to look like my final answer of y equals, we don't really write a 1 out in front, it's implied, minus 2 squared minus 3. This is my final answer. Any questions here?
Okay, so you took that 0.41, you plugged it in. What is that final answer? Like, what is that?
This is the equation for this quadratic formula here, for this, excuse me, quadratic
And you
equation.
found that just by plugging in that 1 point into their respective variables.
Using the vertex that I was given, yep.
Yeah, okay.
100%, yep. So like, let's say, for example, this a value was 2, right? Let's say it was more interesting. Then there would be a 2 sitting out in front here, and the h and k are the same.
Yeah. Yeah, I get that.
Cool. What else we got?
Are we gonna have to memorize that equation?
You should know how to do this. Yep. You should know vertex form, intercept form, and standard form.
Okay.
Anything else here? Cool. All right.
Can we do another one?
Yep. I don't know that I'm going to do one of the exact same because they're all just the same process with different numbers. So you can go check out similar ones online with different numbers like the ones I posted in Google Classroom today. There are definitely others we are going to do though, like this one. People okay with this? Goodbye. Here we go. So now I've given you 2 x-intercepts. Whoops. So we have an x-intercept at 3, 0, x-intercept at negative 2, 0. So I'm just going to write these 2 points as my x-intercepts. Whoops, that was a bit aggressive. And the first one, again, is at negative 2, 0. Other one is at 3, 0. And then we also have this point. And the point we have here is negative 1, 2. So now as I'm looking at this problem here, I do have an intercept form. So intercept form looks something like this. Where I've got my y value is equal to a, and then we have x minus p, and we have x minus q. So there is a slightly more complicated version of this where we have like alpha x minus p and beta x minus q. And the reason for that is like it can get a little bit more complex. It doesn't just need to be a simple one like this. So like 2x minus 3 for like an intercept where like we're going to get 3 halves as my actual like x-intercept value. So it does get slightly more complex, but we're going to keep it simple to start here. So when we're looking at this, okay, now how can I fill in some values? Well, I know I have x-intercept at negative 2 and 3. So to go from a 0 to an actual factor, it's going to look opposite, right? So like when I plug in negative 2, it should spit out a 0. So if I had a 0 of negative 2, what I'm saying is that x, I don't want to write this out. So I got x equals negative 2, that's my 0. So how do I turn this back into a factor where it's set equal to 0? It's going to look like plus 2 on this side, plus 2 on this side. So I get x plus 2 equals 0. Again, so here's my factor that gives me this 0. So for the other one, it would look like x minus 3 equals 0. So now these are my actual like factors. So this is my p and my q values here. So again, p of -2, q of 3. These are being plugged in. It looks opposite. So again, just because I'm subtracting p, subtracting q. So let's make this look like x plus 2 and x minus 3. I've got y equals, actually let's keep that in yellow. So just based off of the intercepts here, I get my factors, and that's where this comes from. And so now once I have it like this, I'm saying, okay, well, I need to solve for the a. How am I going to solve for the a? Well, I'm going to solve for a by plugging in this point that I know works. Okay, so 2 is my y value. So I'm going to say 2 is going to be equal to, and now the a I still don't know, so that's a. And then the thing that I do know now, my x value here, is going to be -1. So -1 and -1. I'll try and keep the colors the same here. So +2, -3. I guess I should have kept the a value yellow. So just like that, never happened. And so now that we've plugged in our x and y values, we're just going to do some math and solve for a. So when I'm doing this, I'm going to add these things or subtract these things together. So -1 plus 2 gives me 1. And I here I have -1 minus 3 will give me -4. And I have a times all of this. So this is just going to be -4a equals 2. So I'll divide by -4. And I get a is equal to -1/2. So that's not my final answer, but I'm very, very close. So now I've solved everything I want to solve for. I know my a value. I know what it's going to look like in terms of factors. So my actual final answer is going to look like y equals -1/2. Here I have x plus 2, and I have x minus 3. So this is what I'd want to see as a final answer here. Any questions on this one in intercept form? There's no need to FOIL this out too. Like just leave that as your final answer. That's totally fine. What else we got? We're good? Alrighty. Let's look at another example, and this time let's use a bunch of points. So I'm just going to kind of buzz through this because we're not going to do a ton of this. It's cooler to do with stats, but we're not doing stats, so we're going to just kind of skim the top level, and we'll tell you how to do it in terms of our quadratics. So here, if we have a bunch of points, we can kind of get like a line of best or a curve of best fit. So we can like fit quadratic regression, linear regression, like all these different things to try and model different data. So this data looks like a curve, so I'd use like a quadratic. If it looked like a line, I'd use linear. So when we're doing this thing, it's saying, okay, use these points. So the main purpose of this problem is just saying, grab these 3 and figure out what the quadratic would be generated off of these 3 points. So basically you could go in, we can use our TI-84, 83 calculators, or I'll show you how to use the emulator online for matrices to do this. But basically we're going to end up setting up a bunch of equations based off of ax squared plus bx plus c. So I'm going to show you guys what that looks like. And we're going to take, we just need this picture. That's a smidge smaller than I like, so let's do this. Or not. Okay, well, let's do a different workaround then. There we go. The reason I just don't want to do that from Paint is because then it's stored as a bitmap image and it gets super distorted. So now that I have these 3 points, this is really what I care about. So I'm going to start out here with talking about what my points are. So my points for this problem are 20, 25. I get, oops, I want to do each of these in our color. $40, $30, and then my last one here, which is $60, $28. And so now what I'm trying to figure out is a quadratic equation in standard form. So what is standard form? Standard form is y equals a x squared plus bx plus c. Now here I'm looking at a, b, and c as like my variables. Those are the things I'm trying to figure out, although I understand that x is a variable and y is a variable, but those are things that we plug in and then y is what we spit out. A, B, and C are going to be just constants that once I figure them out for the equation aren't going to change. So using these 3 points, I want to figure that out. The way that I'm going to do that is I'm going to first use this point, and I'm going to come up with an equation, and I can also just throw my y over here, and I'm going to end up using it in this orientation, and you'll see why in a second. So when I'm doing this, I'm going to say, okay, well, let's plug in these values and see what we get. So I get a times 20 squared plus 20, well, do b times 20 plus c equals, and now I'm going to plug in my y value here is 25. I'm going to simplify this so I get 400a plus 20b plus c equals 25. And that's one of the 3 things that I'm going to end up using. So again, I have a 3 variable equation here. If I wanted to solve a 3 variable equation, I need 3 equations, assuming that none are like just duplicates of the other. So when I do this, I'm going to do this 2 more times. So I'm just going to again walk through how I did this part in red, and then I'm going to do it in green and blue. So as I have this point, I'm plugging this x into my x squared here and into my x here. So it's going to be a times whatever that thing is squared, b times whatever that thing is, and then plus c is going to equal whatever the y value is. So here is 25. So I'm going to do it again in green. So here I'll have a times here now is 40 squared plus b times 40 plus c equals 30. So now again, I'm just going to simplify this a little bit. 40 times 40 is going to give me 1600a plus 40b plus c equals 30. And now I have my second 3 variable equation. Again, we should be thinking, okay, if I get a bunch of 3 variable equations, I'm definitely not solving this by hand because that's a pain in the butt and I don't want to do it. Far too lazy for that. So here now, my last one, a times 60 squared plus b times 60 plus c equals 28. We get 36 hundo a plus 60b plus c equals 28. And so now I have my third equation here. So when I am looking at this, I now have my three variable equations required, trying to round that out, to solve this problem. So if I gave you three variable equations, excuse me, what I would be looking to do is to turn this thing into a matrix. So I'm looking to turn this thing into a matrix that's going to look something like this. My dimensions for this thing are going to be 3 by 4, As I look at these values, I've got 400A, 20B, and then 1C. So I should have 400, 20, 1, and then 25. Now again, if you want to do like the whole little dotted line here to separate our solutions in the augmented matrix, then that's fine, but you don't really need the line there. Here we got our green values, 1600, 40, 1, and 30. And then we've got blue here, which was 3600, 60, 1, and 28. And now I'm going to use either my TI-8384 calculator, or I don't have that, and I'm going to say, okay, well, I'm going to go online then instead. So here now I'm going to go to this website, which I posted in the Google Classroom, and I'm saying this is a 3x4 matrix. I'm going to have to flip back and forth unless I can figure out a clever way to do this, which is sweet because we're wizards.
So for this question, are you going to ask, like, take this graph and turn it into a matrix?
I'm solving 3 variable equations using a matrix, but we don't need to turn the graph itself into a matrix, if that makes sense. So using reduced row echelon form is a very clever way of solving it.
Okay.
Good question. Do all the work for me, please. Because we don't want to do it by hand. Been there, done that. And now we just go to calculate at the bottom here. You can show the steps or not, doesn't really matter. It's kind of cool to see the steps, but again, we didn't do a whole lot of like the actual like reducing of the matrix using like row multiplication and stuff like that. So again, when it's saying like use column 1 as a pivot, like it's all the stuff we talked about, but blah, 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 we already did that. We're super smart. Boom, here's our answer. Whoopsie. There we go. So again, I'm going to be looking for an answer like this. If you had an answer like this, it better be just because I said round to 2 decimal places or something like that. So this would be my actual like solutions here. Whoopsie. So I'm going to grab this and we'll jump back here. So now what does this mean in terms of writing out my final answer? The final answer thing that I want is going to be in pink, and it should look like y equals, oops. And now again, ax squared, so what's my a value here? A is the top one, this is the first one, so negative 7 over 800 x squared plus 31 over 40, my b value, x plus my c value, 13. This is the final answer that I would want to see on an exam. And this is fair game. Any questions here?
Wait, so once you have the matrix, like the thing you have on the screen that you drew,
Mm-hmm.
what do you do with it? Do you kind of, is that like the, like what do you do in the calculator?
This is where we do reduced row echelon form. So this is like the second matrix, and then we go to math, and then we go to option B, which is REF. And then we grab the matrix we entered into, say we entered it into matrix A, that's what we're going to be entering in, and then on that main screen we just hit enter, and it should spit out the same matrix. Did you get the same thing?
Yes, I did.
Perfect. Again, we may have to hit math frac to take care of the messy decimals into nice things, but that's easy enough. Any questions here?
Is there any way you would be able to post a lesson for 5.7?
I have 5.7 homework solutions I posted up, which is a pretty decent representation of 5.7 in general. 5.7 really is mostly just, do you know 5.1? And that's like the graphing stuff. But we can definitely talk about it, and I'm going to answer any questions that you guys have regarding it.
Okay.
How do we feel with the 5.8 lesson? Are we good here? Are we able to wrap this up? Perfect. All right. YouTube Nation, subscribe to this thing, smash like, share it with your friends. Tell me how to stop the recording. You know, all of those things. I think I have to literally, here we go.